Next up, we have Jay Dawani. Jay, come on up. Let's give Jay a round of applause. CEO of Lemurian Labs. We said we're part of the cool Veil, like flannel jackets club.
Well, it is GTC, and we kind of have to wear a jacket.
That's right.
Leather jackets are trademarked.
That's right. Different kind of jackets. We don't have to copy. We don't have to copy Jensen. Awesome, Jay. Glad you're here. Thanks for this.
Thanks for having me.
Tell us about your background. I know you were involved in robotics, and you're one of the early people at OpenAI. And tell us about your background and how you got involved in what Lemurian Labs is today.
Yeah, went to school for applied math. Met 𝗃𝘆 just when I was going in, and got eventually convinced that neural networks were going to be the rage, and that they were finally working, and they were. Got pulled into a company called OpenAI in 2016. Worked on some of the early robotics things. From there, worked on self-driving cars, landing rockets, putting robots on different planets, and eventually started a company called Lemurian Labs, where we finally started with a chip. And turned out that was really, really hard.
Yeah, talk about that. Talk about starting with chips and hardware, and why you did that, and then why you made the shift from chips to what you're doing now with Lemurian.
Yeah, so when we simulated our chip, and it was like an order of magnitude more performance than what was out there in the market at the time, we became convinced that, you know what, maybe chips are the answer. But when we started simulating future chips, we learned that the historical thing of software getting faster and developers getting free gains was going to come to an end. So we kind of saw the end of the paradigm of accelerated computing in a way, and the beginning of what we're starting to call accelerated software, where developers have to put in the work to get the performance gains they're used to getting every new generation of chip. And that led us to really rethinking a lot of things. And then if you couple that with the explosion that you're getting on models and different architectures on the compute side and the model side, and how big they're getting, how quickly they're getting, it's really hard to do the performance engineering work. And something had to change. So we went back to the drawing board and reinvented how compilers and runtime is going to work from our point of view of what we need for scale. We believe in a world where 1 billion agents are in the world. Right? Every single company, every single person has their own agent, essentially building on the sovereign AI concept. And each agent is roughly like an exaflop in compute, right? So if you put that all together, you're getting like 10 to the 30 flops in a single day. That's 10,000x more compute than has existed in all of humanity, right? So where does this come from? And a lot of things have to go and evolve to support this. And that became how we thought about the software stack. Like there's about 2 orders of magnitude of performance there, and it creates a whole new set of unlocks for the model layer and the model companies. So how do we give them that acceleration?
Yeah, you mentioned that crossing the CUDA moat isn't just about kernel optimization. You guys are working on something that goes beyond even that.
If you believe in AI inference and a world where AI is for everybody, you believe that there's enough room for 10 NVIDIAs. So it's not about breaking NVIDIA's moat, it's about enabling the other 9 and NVIDIA. And if you do that, you essentially have to throw away the notion of kernels, because kernels don't exist in a heterogeneous world in the same way. You have to think about the maximum performance that is achievable for a workload. And our stack essentially generates all of the kernels for every single hardware that it targets for the highest performance, and then everything else is a scheduling problem, right? In modern chips, memory access and data movement is much more expensive than doing any ops. So why are we writing things for saturating an ALU, which we cannot do? Right from the point of view of data movement. And how do you minimize that? And that'll give you much more performance. So in a large HPC system, data acceleration or movement is far more costly. And that's where most things are stalled. Right? Everyone today is just talking about a kernel launch, which is 10% of the system. So we built something that does what everyone else told was impossible. Built a dynamic runtime that can actually solve heterogeneity. And we brought this up on the MI300. We've done some tests. Right now, our kernels that are just compiler generated are 2x the performance of ROCm. right? And what we're seeing going towards Nvidia is we're, like 30, 40% faster there too.
Like it. I know you and I have had conversations about your motivation for why you want to overcome the CUDA moat. Maybe you can share why this is important to you and a conversation you had with Jensen.
I don't know if I want to go there today.
I don't think he's listening. I don't think he's here.
I was looking at robotics for a long time, and the chip that Nvidia was building wasn't going to get us there. So the architecture that I designed back then was very close to what O3 looks like. Very dynamic in nature, but obviously when you're doing something low latency inference on the edge, you're effectively operating at batch one. Right? The GPU is not built for batch one inference, and it wasn't built for dynamicity. So I asked them if they would make a certain set of architectural changes, and they said no. And they basically drew out the NVIDIA stack and how things work. They're like, we're not going to change this. This is how the company runs. And I basically said, I'm going to go build my own chip then. And I do believe in a world where every single person has access to AI. Like, it's beneficial to the world. Right? We haven't seen real economic growth in over 20 years because there hasn't been something like the internet or electricity or the steam engine to be that catalyst. But now we have AI. But it requires compute being massively unlocked for that to happen. And if CUDA remains a moat and NVIDIA is the only option, we don't get there. And that doesn't feel just. So that's what I'm really in it for.
That's right. Awesome. Let's give Jay a round of applause. Thank you so much.